everyone. This is the first video in our absolute value functions topic. This is the first thing we're learning about this year. So first, I want to talk about what absolute value is and some applications outside of school, just so you know what it is, and then we can talk about what we're going to learn about in this section. So if you're following along in your notes, this is actually on the second page. I'm going a little bit out of order. So one application is dealing with the transfer of money, depending on who, your accountant is. So let's say that you owe me money. That will show up on my sheet as a positive number, but yours as a negative number because you owe me something and I will be gaining something. But the transfer of money, it's always a positive amount of money. Because remember that absolute value is the positive value. It's the distance away from zero, the positive value. So the absolute value of -5 is just 5 because it's 5 steps away from 0. Direction doesn't matter, in other words. So this is like an accounting application. And then another application is in physics and calculus, and just your life. Distance is just a life word. So this is using absolute value concepts. So distance is the absolute value and the difference in position between 2 points. And it just means that direction doesn't matter. So if you go, 3 miles northwest, it's the same distance as when you go from, the place southeast back home. It's the same distance. It's the absolute value. And that's what this A minus B is the same as B minus A. That's just saying the distance. Because distance doesn't depend on direction. So those are some applications, and what we're going to learn about are transformations of absolute value functions. So we're going to learn about what this function looks like. So if you graph the absolute value of x, which remember is using these brackets, these guys right here, these brackets, this absolute value of brackets, so it would be like the absolute value of x. So, and this function ends up looking like a v. And this, we're going to learn about how to move this graph on a coordinate plane, what that looks like in the function form and the equation form like this. And one application or a continuation of what you've learned before is with tessellation. So you learned about sliding objects. So you slide objects up, down, left, right. You can shrink them. You might have learned the word dilute. You might have dilute or shrink or stretch. And then you rotated items. So like tessellations. Like this. See all these V's in here? It's like the coding behind math art, really, tessellations and absolute value. So this is a V. You could code this as an absolute value function. And you create tessellations by translating it then right a little bit over here. So this is a more abstract way of thinking about like tessellations and moving things around and thinking, applying the like equations and function side of it too. All right, so what we're going to learn, like the key idea here is learning what the values a, h, and k do to the graph of the absolute value of x. So remember, a, h, and k are variables. X will always stay the same. X is x. It's like the x-axis. So we're going to put like 2 in for a, 3 in for h, 8 in for k, see what happens, okay? And we're going to be able to describe what happens when you put any number in any of those positions. Learning targets, we're going to translate the graphs, which means slide, move left to right, up and down, stretch, shrink, and reflect. Stretch is to make it larger, either side to side or up and down. Shrink, make it smaller, or reflect, so a flip. And then you can do a combination of transformations. So those are our key ideas. And so now we're just going to talk about what is an absolute value function and talk about a little bit of vocab in this video. And then we'll move on to shifts. So an absolute value function is a function that contains an absolute value expression, which are these symbols here. And it ends up being this V. This is the absolute value of x. And this is what it looks like. You can use Desmos to check. And if you're curious, you can plug in some values of x and see what happens when you end up with a y. Some of you might say, this is a line. This looks linear. And it is. It's like a linear equation reflected and then combined. So it makes a V. Okay, now let's talk about parent function. The parent absolute value function is this. absolute value of x. That means you're not adding anything to it, you're not multiplying anything to it, it's just in its simplest form. Parent means the simplest function in that function family. And a function family is all functions that look the same. So like all of the v functions are going to be absolute value functions, whether they look like this, or shifted up, or shifted over. They're all part of the absolute value function family. Okay, so then we'll have, let's observe. What do you notice? You might notice that, it's a v, and the parent function has the vertex, which is the point of the v, at 0, 0, at the origin. You might notice that this goes up 1 every time you go over 1. In other words, this has a slope of 1. Rise over run. And then you go on the other side, this one also goes up and over 1, but we're going backwards, so this line is going down, so the slope is negative 1. There are some things you might observe. You might observe some more. And last in this video, let's talk about some vocab. So, we're going to talk about domain and range in this class. And that just means, in terms of functions, to be a function, for everything you put into the function, think like function machine. So a function is like a machine. This is the function. F of x is our symbol for function. And you put an input in, and then you get out one output. And this is what a function is. Absolute value, you put in an x value, that's what input is, and you get out one y value, that's what the output is. So then domain are all of your possible inputs. And then your range are all of the possible outputs, or all of your possible y values. In other words, where does the graph go? So for example, absolute value looks like this. Domain is how far right the graph goes and how far left the graph goes. You might think, well, there's no limit. And there's not. You can put in any x value and you'll get something out, which means that the domain are all the real numbers. Is all real numbers. And remember that a real number is anything that is not imaginary. So it doesn't have the letter I, which just means we got any integer like 1, 2, 3, 4, negative 1, 2, 3, 4, 0. We got all the fractions. We have even some irrational things like pi or e or, I don't know, the sevenths, like 2 sevenths. So all real numbers, that's a real number, remember. And then the range for absolute value. Keep in mind, the graph looks like this. You can see it up here, so you don't have to draw these if you want, but the range is how low it goes. What are the y values? Does the y go down and down forever and ever, or does it have a stopping point? Does it go up forever and ever, or does it have a stopping point? You might say, okay, Ms. Anton, this looks like it's just going to keep going up and up and up forever and ever, and you're right. Which means it doesn't have a top limit, but it does have a bottom limit. This is the lowest point on the graph. Where is that? 0. So what are all the possible values of y? Anything larger than 0. And whenever I ask you to tell me the domain and range, you can use symbols like this. Y has to be greater than or equal to 0. Or you can use, if you've seen this before, I'm not sure if you've seen this before, but the range is between 0 and infinity. Using a bracket for 0 because it's included in the set, and a parenthesis for infinity because infinity is not like a number, it's a limit. Or you can just use your words and you can say y is larger than 0. Any way that makes sense to you to communicate that to me is fine with me. If just saying it in words is how it makes sense to you, then just do that. There's no need to make it complicated with symbols. I'd like to get to that point at some point, but right now, words is absolutely fine. Okay, and that is it for this video. email me with any questions that you have, all right?